Hi guys, your Friendtor Gopika is here, and in this video we will discuss some solved examples and their applications of all the theorems that we learned in the previous videos, that is the Pythagoras theorem, converse of Pythagoras theorem, 30, 60, 90 degree triangle property, then geometric mean theorem, then similarity of right angle triangle theorem. All these theorems we will see how to use them in problems. Okay, so before getting into the first, or before starting with the first exercise in the chapter, it's important that you go through some problems of how to apply all those theorems. Okay, so without wasting time, let's get started. Okay, so this is the first example. So first let me choose a pointer. Okay, so in the segment 2.11, in triangle APC, angle B is 90 degree, angle A is 30 degree, angle C is 60 degree. Okay, so this C 60 degree is not in the question, but in the diagram it's evident. If one is 90, another is 30, the third angle has to be 60 degree. Then what is given is AC, that is the length of hypotenuse is 14. We need to find AB and BC. So clearly this is a application of 30, 60, 90 degree theorem, wherein it says that BC is, or the side opposite to 30 degree is half of hypotenuse. So BC is half of AC, and side opposite to 60 degree, that is AB, is root 3 by 2 into hypotenuse. So very simple applications. So now substitute the value of AC in both the equations. Then half into 14 is 7, and root 3 by into 14 is 7 root 3. Okay, very simple application of 30, 60, 90 degree theorem. So let's see the next example. Okay, see figure 2.12. In triangle ABC, segment AD is perpendicular to BC. So if you see this AD is perpendicular to BC. Next, angle C is 45 degree. Okay, and BD is 5, and AC is 8 root 2. Okay, then find AD and BC. So what we need to find is AD and BC. So in the diagram itself, okay, in the question they haven't mentioned about side DC, so that we can obtain using 45, 45, 90 degree theorem. Okay, so angle ADC is equal to 90 degree, angle C is 45 degree, that means angle DAC is also 45 degree. Okay, since it is 90, this is 45, then the third angle is also 45, because sum of angles of a triangle is 180 degrees. So using that angle addition property, we can find the third angle to be 45 degrees. Next, what we know is we apply the 45, 45, 90 degree theorem and say that AD, that is the side opposite of 45 degree angles, AD is equal to DC is equal to 1 by root 2 into hypotenuse. So the here hypotenuse value is 8 root 2. So 1 by root 2 into 8 root 2 is same as 8. So DC is equal to AD is equal to 8. So what we need to find now is BC. Okay, so DC is 8, BD is 5, then BC is 5 plus 8, that is 13. Okay, again a very simple question, directly applying the 45, 90 degree theorem, 45, 45, 90 degree theorem, and then finding the required side, length of required side. Okay, so let's see the next problem. Alright, so this is example 3, wherein we will use the geometric mean theorem, because if you see this triangle PQR, from the 90 degree vertex we drew, the construction is from 90 degree they have drawn a perpendicular towards the hypotenuse, that is QN. Then they have given values of PN and NR, these two segments to which the hypotenuse are divided. We need to find this perpendicular. So clearly the formula or the theorem relating to the perpendicular drawn from the vertex to the hypotenuse and the lines to which the hypotenuse are divided, segments to which the hypotenuse are divided, is geometric mean theorem, wherein it says that QN is geometric mean of PN and NR. That means QN square is equal to PN into NR, and that is same as QN is square root of PN into NR. Okay, so NQ is equal to square root of Pn into Nr. Pn is 9, Nr is 16, Now n is 3 square, 16 is 4 square. So 1 3 will come outside the root, 1 4 will come outside the root. When you multiply, you will get 12. Okay. Otherwise, suppose if you multiply 9 into 16, you will get 144. Again, root of 144 is 12. Okay. The calculation part you can do. The steps you can follow as you wish. Anyhow, the answer is 12. Okay. So the length of the perpendicular QN is 12. Direct application of geometric mean theorem. Okay. So now let's see next example. This is example 4, wherein there is a figure 2.14. Here we need to find three values actually. Value of x, value of y, and value of z. Length of all these three segments we need to find. Here angle PQR is 90-degree angle. Okay. Again a similar construction is made. From Q towards the hypotenuse a perpendicular is drawn. And we need to find x, y, and z. Okay. Now first thing, this x we can find very easily using geometric mean theorem. X square is same as 10 into 8. Okay. 10 is PS, that is QS is equal to square root of PS into SR by theorem of geometric mean. PS is 10, SR is 8. 10 8s are 80. Otherwise also 10 can be written as 5 into 2. Again 8 into 2 is 16, and 16 is 4 square. So 4 will come outside, and within the square root 5 will remain. So x is 4 root 5. Now once you find x, we can find z by considering the triangle PSQ and applying the Pythagoras theorem. And below in triangle QSR also we can apply the Pythagoras theorem and find y. Okay. So in triangle QSR, first we start with this smaller triangle. In triangle QSR, QR is the hypotenuse. Since angle QSR is 90 degree, QR is the hypotenuse. So by Pythagoras theorem, QR square is equal to QS square plus SR square. Okay. Now QS value is 4 root 5. So 4 root y square plus 8 square is equal to y square. So 4 root y square will be, 4 square is 16, root 5 square is 5, 16 into 5 plus 64, 16 5s are 80, 80 plus 64 is same as 144. So QR that is equal to, that is y is equal to 12. Okay. Once you get that, consider the another triangle, that is the PSQ, the upper triangle PSQ. There also PSQ is 90 degree angle. So PQ is the hypotenuse. Hence by Pythagoras theorem, PQ square is same as QS square plus PS square. QS is 4 root 5. PS is 10. Substitute the values. 16 into 5 plus 100, 180. That is same as 36 into 5. Therefore PQ is 6 root 5. So X is 4 root 5. Y is 12. And Z is 6 root 5. Okay. Again a very simple example. So let's see the next example. Example 5. In the right angle triangle, sides making right angle are 9 cm and 12 cm. Find the length of the hypotenuse. This is clear cut substitution of Pythagoras theorem. Nothing to think about. Just check, just draw a diagram. PQR is a 90 degree angle. Substitute the, mention the Pythagoras theorem. And PR square is equal to PQ square plus QR square by Pythagoras theorem. Hence, PQ is 9, PQR is 12, so substitute the values. 9 square is 81, 12 square is 144. When you add, you will get 225, and 225 is same as 15 square. So PR is square root of 225, that is equal to 15. So hypotenuse is 15 centimeters. Okay. Very simple, very much direct application of Pythagoras theorem. Okay. Okay. So this is the sixth example. In triangle LMN, L is 5, M is 13, N is 12. State whether the triangle is a right angle triangle or not. Okay. Now here they have just given the, mentioned the length of three sides of a triangle. We need to check if it is a right angle triangle. So here we will be using the converse of right angle converse of Pythagoras theorem. So just like we check if the three numbers are Pythagorean triplet, follow the same steps. So the largest number is M. So M square is 169. Next, L square is 25 and N square is 12. Now add L square plus N square. You will get 25 plus 144 same as 169. So that means L square plus N square is same as M square. So m square is equal to L square plus n square. Now by converse of Pythagoras theorem, what does converse of Pythagoras theorem say? Whenever you have a triangle with square of one side equal to sum of squares of the other two sides, then that triangle is a right angle triangle. Okay, hence triangle LMN is a right angle triangle. Okay, very simple application of converse of Pythagoras theorem. Now let's see the next problem. Okay, this is example 7. See figure 2.16. In triangle ABC, segment AD is perpendicular to BC. So here AD is perpendicular to BC. Prove that AB square plus CD square is equal to BD square plus AC square. Okay. So according to Pythagoras theorem, in this triangle ADC, this ADC angle is 90 degree. Okay. So hypotenuse will be AC. AC square is equal to AD square plus CD square. Okay. That means AD square is same as AC square minus CD square. Okay, we take CD square to AC square to the other side, CD square to the other side, and AD square we keep it alone and find the equation as AD square equal to AC square minus CD square and mark it as 1. Next, in triangle ADB, this smaller triangle, if you see, AB is the hypotenuse. Since AB is opposite to 90 degree, so AB square is equal to AD square plus BD square. That means AD square is same as AB square minus BD square. Okay. So from, if you check equation 1 and 2, we have two values for AD square and for AD square. Two different values for AD square. Now that means AC square minus CD square is equal to AB square minus BD square. Correct? From 1 and 2. Since LHS is same, LHS is AD square, the RHS also should be equal. So AB square minus BD square is equal to AC square minus CD square. Now just take CD square to the other side, so it will become positive. Take BD square to this side, so it will become positive. And this is what we had to prove. AB square plus CD square is equal to AC square plus BD square. So just by applying Pythagoras theorem to these two triangles, we obtain two different equations for AD square, and we know that they match, and hence we obtain the proof. Okay, so that's all with the solved problems. Now in the next video, I'll be discussing the first practice set and the only practice set of this chapter. Actually, I mentioned the only practice set because for the 2021 batch, SSC batch, as you know, many things have been reduced and they have cut the Apollonius theorem and applications of Pythagoras theorem part, and they have cancelled the practice set 2.2. Okay, this is for just board exams. For board exams, these topics won't come. But if you're preparing for some other competitive exams, or if you're interested in maths, I would suggest that you go through that topics also. Anyways, in Friendtor channel, we will cover all the topics. Okay, so if you need to know which part is reduced, please do watch the videos or the playlist in which we had mentioned what all things are reduced for 2021 SSC batch. This is just for this year batch students. Due to COVID-19, teachers and students are finding difficult because everything is happening through online sessions. So to reduce the workload, the board has decided to reduce these things. But for other batches or for future batches, all these topics are really important. And for this batch students also, in board exam point of view, the questions on the cancelled part won't come. But if you're thinking to take up maths in future, if you're interested student, or you're planning to do some competitive exams, these things which are cancelled are maybe really helpful for you. So all the interested students do watch the other part videos too. Okay, so in next in the next lecture or in the next video, we will discuss the first exercise, that is exercise 2.1. Okay students, thanks for watching. If you like the video, please share it with your friends and please subscribe the channel. You can also follow us on Instagram and post your queries. And if you have any doubts regarding any lecture or any doubts regarding maths, then please write in the comment section. We will respond as soon as possible. Okay, bye.